Okay, so we got the ice table right here. Our initial concentration for acetic acid is 0.2, and then we don't have nothing else. And so we can fill zeros in for that. Okay, so obviously, as we produce the product, we're going to lose some of the reactant, and we're going to gain. And based on the stoichiometric ratio, it's going to be 1 to 1 to 1. And so we're going to end up with 0.2 minus x, and then we'll have x and x for these guys. Okay. Okay, now we're gonna find the, or let's set up our equation. So we know that the equilibrium constant is equal to the concentration of the products. So hydronium and acetate divided by the concentration of the reactants and then acetic acid. Okay, so we got that. Oops, why did I cue that? I'm stupid. Mistakes already. Okay, and then we ignore H2O because it's a pure liquid. All right, so we can plug in some numbers now. So we have the equilibrium constant right here. So 1.8 times 10 to the negative 6 is equal to x times x, okay, divided by 0.2 minus x. Okay, and then we can multiply x and x. We'll get x squared. And then we can multiply both sides by 0.2 minus x. So we'll get 1.8 times 10 to the negative 6 times 0.2 minus x equals x squared. Okay. So far, so good, guys, for math? Okay, next we're just going to distribute this value to the other one. So we are going to get 3.6 times 10 to the negative 7 minus 1.8 times 10 to the negative 6x equals x squared. And then we are going to move everything over to one side so we can set up a quadratic. Okay, so we're going to have x squared minus 3.6. Oh, wait, oops, wrong one. My bad, yeah. Minus plus, because we're moving this guy up, 1.8 times 10 to the negative 6x. And then since we're subtracting this, we're going to do minus 3.6 times 10 to the negative 7. And that's equal to 0. Okay, so far so good, guys. Alrighty, now we're going to use the quadratic formula. So x equals negative b. X equals negative b plus or minus the square of b squared minus 4ac all over 2a. See, now you're never going to forget it. And you're going to be 30 like me and still singing this song. You should. That'd be pretty impressive. Okay, so let's plug in our values now. Okay, so we're going to plug in negative b, which is 1.8 times 10 to the negative 6. So negative 1.8 times 10 to the negative 6 plus or minus the square of 1.8 times 10 to the negative 6 squared minus 4. A is 1. B is negative 3.6 times 10 to the negative 7. I'm running out of room. Okay, all over 2a, but 2a is 2 times 1. Okay. Everybody good with that so far? Okay. All right, so I'm actually going to go into this and start replacing numbers just because I'm going to run out of space. So let's start with the easy one. The denominator is just 2. Okay, and then for the b squared, that should give you 3.24 times 10 to the negative 12. Right here, we're going to replace that with 3.24 times 10 to the negative 12. And then we're going to multiply, dang, it's a lot of math. 2.6 10 to the negative 7 times 4. Okay, but since it's a negative and a negative, we're going to get a positive number. So it's going to be plus 1.44 times 10 to the negative 6. Okay, yes. B squared is 1.8 10 to the negative 6. Yeah, we got to square it. No, you're good. Yeah, please stop me. I know there's too many numbers and it gets really confusing, so I'd like to clarify it as we go along. Okay. But everybody good with this so far?
Oh, is this like what's on 8?
It might be, yeah. You'll get like one like this. Yeah. I haven't seen them ever put, huh? So it'd probably be an FRQ question, so it'll probably be part of a long FRQ. And so you'll have 7 FRQs, 3 long, 4 short, 105 minutes.
Okay.
Yeah. So I've never seen them put more than one like this, and if they do, that's because they really hate you guys.
The probability or like a problem like this.
Pretty low, yeah. Yeah, this will be part of a long FRQ. Yeah, one of the part, yeah. Yeah, on your final, there's one that goes to G. So some of them get really long, but usually if there's multiple sections like that, and if there's a lot, the questions are a bit shorter. Yeah. Okay, so where were we? We got this, and then we're gonna add the two values in the reciprocal together. And then that's going to give us 1.44 10 to the negative 6, because this is such a small number, it's not really going to make a difference. Okay, we're going to find the square root of that guy. And so when we find the square root, we are going to get 0.0012. Okay. Okay, so we are almost done, but if you guys notice, this number is a lot bigger than this guy right here, right? And so even if we add or subtract it, it's not going to make a big difference in the number. Okay, so if we add this value right here, we're going to end up with basically 0.0012 divided by 2. That's if we add. And if you subtract it, you're going to get negative 0.0012 divided by 2. Okay, your values might be a little bit different, but this is so insignificant of a difference, and so we can basically ignore it. Okay, and if you punch it into your calculator, you're probably still going to get 0.0012, right?
Yeah.
No? Well, I can check, but 5.89. Okay. 1.8 times 10 to the negative 6. Okay, and we'll make that negative. You add 0.0012. Yeah, 0.001198. That's what I got. Something like that. It's pretty close to that though. So on the calculator, you should be plugging in for this one right here. Maybe you forgot to put parentheses somewhere, but it should be this plus 0.0012 or minus. That might be the issue then. Yeah, but yeah. It should be something very close to this. And if you got something else, you probably messed up the way that you input it on the calculator. Yeah, just be careful. Okay, so which one of these answers are we going to pick? The positive one or the negative one? Yeah, positive, because you cannot have a negative concentration. And so your final answer for X, if I have space, okay, X is going to be equal to basically around 6 times 10 to the negative 4, something like that. Okay. That's what this is. I know math. Math. No, your final's not going to have equilibrium. It's going to go up to kinetics. And then starting next week, we're going to start reviewing.
So our final is not going to have ice?
It's not going to have ice tables.
So what is it?
I'm going to actually go over the topics, in a bit. Yeah.
We both got like that. 1.44 to the negative. I don't know.
Yeah. Well, what's your power? What's your exponent?
Way more than yours.
Yeah, you input something wrong on the calculator. Yeah, so that's why we're practicing. It's to help you guys figure out the inputting too. Yeah, if you didn't square root, that'll make a big difference. Okay, so that's how you do equilibrium ice tables with the quadratic formula. Okay, now this part's very important. Now, if you guys notice up here, I told you guys to ignore this, right? Now you guys are gonna hate me, but you see how we did all this work, right? We can there's actually a trick that lets us know if we need to do all this work. Okay, so what we're gonna do is I'm gonna erase a lot of this and we're gonna just keep the ice table, okay? So we're gonna get rid of this. And what we're gonna do is we're gonna use something called the 5% rule. And I want you guys to write that down, the 5% rule. What the 5% rule is, basically, if the difference or the ratio between X, right, and your reactant concentration is less than 5%, we can ignore X when we're doing our calculations. So we don't need to do a quadratic. And the reason why this happens is because when we use lab equipment in real life, basically the lab equipment can't even detect the difference of 5%. And so if the lab equipment can't detect the difference of 5%, we don't need to do the math for it. Okay, so I'll tell you guys what that means in a second, but just make sure you guys write this down right here. Make sure you write down the 5% rule because it could save you a lot of time on the AP test. All you have to do is a quick calculation. All right, so let me show you guys how to use the 5% rule. So we calculated X to be this value right here. We did all the quadratic stuff. This is what the answer we get with a quadratic. So this is probably the most accurate answer we can get. Okay. So, but now we're gonna test the 5% rule. Now, the way that we test the 5% rule is we do the same thing that we did in the first initial steps. We're going to be solving for we're going to use the equilibrium constant expression. So just exactly what we did. Okay, and then we're going to plug in our values again. Okay, so for KC, we're going to plug in 1.8 times 10 to the negative 6 equals, we're going to plug in X for H3O plus, and then we're going to plug in X for acetate, okay? Now, the part that makes these problems really annoying to solve is this part right here, right? Because there's an X that you're subtracting from our concentration. And so when we test the 5% rule, we can ignore this right here. Okay, and so we get 0.2. And if you look at this problem, this is a lot more manageable, right? A lot less work. Okay, because all we got to do is we just got to multiply both sides by 0.2. And if we multiply both sides by 0.2, we get 3.6 times 10 to the negative 7 equals X squared. Okay, and I want you guys to punch that into your calculator, solve for X, and you will get mad at me. So punch it into your calculator and see what you get.
Yeah, that's the answer. That's the answer we got. We got like 5.9, but that's it.
Oh, that's what you were saying? I thought you were talking about the exponent. Yeah, 5.9 times 10 to the negative 4 is fine. You guys didn't tell me about the exponent, so... Guys, the exponent is the biggest thing. It's the difference between $5 and $500 million. It's the exponent. Yes. Yeah, so X, if you guys punch into your calculator, it's going to be 6 or 5.9 times 10 to the negative 4. Okay, so if you guys notice, it's the exact same number, right? Now, let's pretend that we did not know that this was the answer for X. We need to test the 5% rule. And so this is how you test the 5% rule. You use this formula right here. You use the 5% rule, or the X value you got when you ignored X right here. So you just put it on top. 6 times 10 to the negative 4. And you just divide it by your initial concentration, 0.2. Okay, Okay, and if that value is less than 0.05, then you can use the 5% rule. You don't need to do the quadratic. Okay, so if you solve this problem out, you'll get 0.003. And since that number is smaller than 0.05, it passes the 5% rule. This can be our final answer. However, if this number is bigger than 0.05, let's say you get 0.1, then you got to do the quadratic. Because it's two, the difference isn't, what is it? The difference is significant. It is significant. Your equipment will detect differences in the concentration. Yeah.
So we use this method to find the solution, but for majority of time will it work?
I would say majority of time it will work. So I always recommend try the 5% rule, and then usually it will give you an answer like this. The quadratic, but then if they really want to mess with you, they'll make you do the quadratic. And just a hint, I'll put a quadratic on your test because I respect you too much to just use the 5% rule. Okay, of course, anytime.
We appreciate it, sir.
I appreciate you guys too. Thank you for all this positive reinforcement. I feel like a great educator. Okay, any questions or are you guys chilling? You guys good? All right, I'll leave that up there for another, I guess, 30 seconds, and then we'll move on to the next question. No, you guys seem very sad, even though I gave you this great tool. Why would you be sad? Isn't this fun? Isn't math fun? Oh. No, we're not. You can do that for your final.
Okay.
Yeah, you can. No. So if you want a precursor to math, I don't know if I should tell you guys this in school. I'm gonna talk about history again, okay? So that way it's school related. No, I can record this. So allergy medicine. One of the most common allergy medicines that people use back in the day is pseudoephedrine. Have you guys heard of that? It's in like, it's over the counter. So you know how most of the time right now we use things like Zyrtec, Benadryl, right? They use antihistamines. However, back in the day, and I think it's more effective, people use a compound called pseudoephedrine. If you go to like Target or Ralph's and you go behind over the counter, you can ask the pharmacist for pseudoephedrine. I use it. It works very well. It basically clears all your sinuses. However, a bunch of smart chemists realized, hey, pseudoephedrine is very similar to meth. And we just need to do a couple of easy steps in order to turn pseudoephedrine into meth. And so these people went into probably CVS. I don't know the brand names of the stores. And they went to these pharmacies and they bought cases and cases of pseudoephedrine. Okay, now this got a little sus, right? Got a little suspicious. And then they figured out they were turning pseudoephedrine into meth. And so now you can only buy 1 box of pseudoephedrine every month. And that's why it's behind the counter. You have to show your driver's license, they scan it, and then you can only buy 1 box a month.
So can we make sweet?
You can, but you're not gonna be making it in here. No, I'm not making meth. For the record, I will never make meth. I have never made meth. It's a class 1 restricted compound, and I ain't going to jail. A box of pseudo? No, dude, that's so illegal for me to ask you for pseudoephedrine. No, not at all. If you bring pseudoephedrine, you're not even allowed to bring like Advil to school on your own. You have to give it to the nurse. So don't bring pseudoephedrine in. Yeah. All right, moving on. More equilibrium. Okay. So I'm gonna give you guys some time to try out this problem as well. Actually, let's do this together. But I'm gonna give you guys about 2 minutes to set up the ice table. Don't solve the problem though. Just set up the ice table, and then I'm gonna show you guys a trick to solve this a bit quicker as well. Okay. Okay. So let's set up our ice table. So you guys should have seen that both hydrogen and carbon dioxide are 0.5 molarity. And then we got 0 here, 0 here. That's it. You guys chilling? Okay. Now, the change is going to be minus X for the 2 reactants because this is a 1-to-1 relationship, and plus X plus X. So that means at the very end, you're going to get 0.5 minus X, 0.5 minus X. and then x and x. Okay, so if we take a look at the equilibrium constant, it's going to be K. Okay, and that's going to be equal to the concentration of CO, concentration of H2O, divided by the concentration of H2, divided by the concentration of CO2. Okay. Now you're gonna be plugging your numbers in, so I'm gonna start doing that. So for the top, right, it's gonna be x times x, which is x squared. Okay. And then on the bottom, we're gonna have 0.5x or 0.5 minus x. So 0.5 minus x times 0.5 minus x. Yes, so that was the point. Good observation. So if you guys take a look at this, you guys might be like, hey, I'm going to test the 5% rule, right? That way we can get rid of the x on the bottom, and then we can just do 0.5 times 0.5. However, like Josie just told us, if you notice, this right here on the denominator is just 0.5 minus x squared, right? Because it's there twice. And so we don't even need to test the 5% rule. We can get the most accurate answer possible without doing the quadratic. How would we simplify this equation to make it easier? Yeah, how would we get rid of the exponent?
Square root.
Yeah, we can square root both sides. And if you square root both sides on the left side, you'll get the square root of the equilibrium constant, which is 0.771. And that's going to be equal to x and 0.5 minus x. Okay, and from there, no quadratic necessary, just an easy algebraic formula. Okay. All right. So I'll give you guys about 2 minutes to solve that out. See if you guys can get x. The point of this problem is to just show you guys the better you are at math and seeing these patterns and little steps that you can take, the easier these problems get. Okay, so that's my pitch for math. Okay, math matters. Yeah.
The 5% rule is kind of just like a 5 rule that kind of just a bunch of people follow, but it's not.
Yeah, it's not 100% accurate, but again, it's in the real world because equipment can only detect about a 5% error. We use it because whether you do the full calculation or you don't, it's not going to make a difference in the lab setting. So we can just use 5% rule. So I always recommend testing it out because it does save you a lot of time if it works out. Alrighty, guys. So you should get a final answer of x is equal to 0.234. But he got that? Something around there. And then the question is asking us to find the equilibrium concentration of all 4 gases. So if you guys notice, these are going to be the same, and these are going to be the same as well. So for our final answer, we can write that the concentration of carbon monoxide and the concentration of H2O is just x, so 0.234 molarity. The concentration of H2 and the concentration of CO2 is also going to be the same, and it's just going to be 0.5 minus x, so 0.5 minus x, and that's going to give you a concentration of 0.266 molarity. And that's your final answer. Okay, so just make sure that when you guys are solving problems on either your homework or on the exams, on the AP test, that you guys answer exactly what the question is asking you to give, okay? Alrighty. You guys think you could try one on your own, beginning to end?
Yes. Yeah.
Yeah? No? Well, too bad. Maybe so. Okay, we're gonna move on to 12.23, so you guys can scroll down onto there. This one's a little bit trickier because if you guys notice, 12.23, the stoichiometry, there are finally coefficients. So just make sure you keep the coefficients in mind when you guys are doing the change, the C row in the ice table. So I'll give you guys about 10 minutes to do this one, beginning to end. Actually, that's a little too much time. 7 minutes. And then after that, we'll take our break. Okay, so 7 minutes to try this out, beginning to end. Good luck, everybody, today. This semester, actually. Okay. So, if we take a look at this problem, first thing you should have noticed is that it is not in molarity. Okay, so you had to calculate the molarity of nitrogen dioxide. Should have gotten 0.25. Okay. All right, next thing we're gonna do is we are going to use the ratios with the stoichiometry. So 2, 2, 1, so minus 2x plus 2x plus x. Okay. All right, and then from there, we can set up our equilibrium concentrations, which is 0.25 minus 2x, 2x, and x. So far, so good? All right, so our equilibrium constant is equal to the concentration of NO, but we gotta square it, right? The concentration of O2 divided by the concentration of NO2, and we gotta square that. Okay. Everybody good with that? Okay. So we are just gonna plug in our values now. So for the equilibrium constant, it's gonna be 1.2 times 10 to the negative 5 equals, now on the top, we gotta do 2x squared times x. Okay. We gotta divide that by 0.25 minus 2x. All right, now, if we take a look at this. Oh, thank you. Thank you. Now, if you guys take a look at this, you will notice that this could be a problem because you're gonna have a really, really hard time solving this. Okay, but we are going to use the magic of the 5% rule. Okay. And so I always recommend trying the 5% rule, especially as the equations get uglier and uglier. Okay. So if we use the 5% rule, the part that we are going to get rid of is this part right here. Okay, minus 2x. So we're going to get rid of minus 2x. And just by doing that, it becomes a much more manageable equation to work with. 5% rule, we're going to assume that the difference in the concentration will not be that significant. Yeah, that's the 5% rule. I recommend doing it to all of them. And if it passes the 5% rule, then you can just use your answer. Okay, so first thing you want to do is you want to multiply both sides by 0.25 squared. And on the left side of the equation, that is going to give you 7.5 times 10 to the negative 7. And I simplified all that. Okay, on the right side, we're going to get 4x squared times x, so 4x cubed. Okay. Make sense? Okay, so let me rewind. What we did was here, I'll show it up here, just the steps. So what we did was we first did 0.25 squared. Okay, it's going to be that value, and then we're going to multiply both sides by it. So we're going to multiply 1.2 times 10 to the negative 5 by this number, and that'll give you 7.5 times 10 to the negative 7. All right, next thing that we're going to do is we're going to isolate the x, right? So we're going to divide by 4 on both sides. That's going to give you 1.8, about 88 times 10 to the negative 7 equals x cubed. Okay, and then from here, super easy. We just find the cubed root for both sides. Now, if you guys don't have the cubed root on your calculator, what you can do is you can raise both sides to the power of 1/3. That works as well. Okay. Okay, if you find the cubed root on this side, you'll get x. And then on the other side, x is going to equal 0.0057. All right, now we just need to make sure that this guy passes the 5% rule. So what we're going to do is we're going to take our x value, 0.0057. We're going to divide it by the initial concentration, 0.25. And that's going to be 0.002. And so it passes the 5% rule. So we can just stick with that for the X value. Okay. Okay, so technically we're not done. We are not done because we need to figure out the concentration. So if you take a look at the problem, it's asking not for X, it's asking the concentration for all the compounds. Okay, so the easiest one is obviously going to be O2 because it's just X. So we can replace that with our X value. So 0.0057. Okay, for NO, we're just going to double it. So we can do 2 times X, and that's going to give you 0.0114. And then for this guy, we can keep it 0.25 because it's not going to make a big difference. But if it looks like, if we give an answer, the initial and the equilibrium concentration being the same, it might look a little bit weird, right? Because it's saying that we lost some, but it didn't change. So I would recommend just doing the subtraction. So do the 0.25 minus 2x, at least just for the very end part, okay? And so you'll get a final answer of 0.2386. Yes. I would write it out just to clarify it for them. Yeah, just so that they don't have to work for your answer. You want to make sure it's easy for them to access. Yeah. Well, I mean, if they're a jerk like me, I'm just gonna take points off. So, well, then you're shooting yourself in the foot. So, but you know what? Power to you. You can do it however you like. All right, guys. So that is the last new thing for this semester. We're gonna cut it right there. So congratulations, guys. You guys did 11 or 10 and a half units of hard work. All right. Yes.
If you wrote